All right. Okay, ladies and gentlemen. Today's lesson. Today's lesson is very heavy on vocabulary. Not a lot of math, a lot of words and concepts, though. And we're going to start right off the bat with the first word, a set. You guys already know this from your lessons in other courses where you drew Venn diagrams. You all know what a Venn diagram is. For some reason, Venn diagrams have been stolen by English, even though they're a math thing. But English teachers love Venn diagrams. Yeah. They're a math thing. But that's cool because it is actually good because it makes you see that the stuff you learn in one class can work in another class. So you already know what a set is. But in math class, does anybody know what a set is? In math class. In math class. A group, okay. I kind of dig that. But I'm not going to write that down yet because we're going to take a moment. Because it doesn't have to be a group. You're on the right track. It doesn't have to be a group. Can anybody want to refine Carlin's guess at what a set is after I just told him he said it's a group. I said it doesn't have to be a group. Does it have to be more than one? Can I not have an empty set? Right? For example, if we had, what is the set of individuals in this room that are over 60 years old? I'm just going to pause the recording for a moment. No, there are no individuals over 60 in the room, but I'm going to help you out. What is the set of individuals over 50 in the room? Okay, still not quite right. I'll help you out again. What is the set of individuals over 40 in the room? I'm a little fat, Jashin, but 4 of me? Really? 4? I know, because every time I say your name, you say something different. Jashin Deep? No. You've never told me how to say it otherwise. But how can I say it properly when you've never told me how to say it properly? Okay, then correct me. I am waiting for it. Okay. Okay, I will. Where was I? Oh, yes. Set of individuals over 40 in the room. 1. Excellent. So everybody understands that I am a set. Am I a group? No, I'm one thing. Okay, now, what is the set of individuals between 10 and 20 in this room? However many are here. Assume everyone's here, which isn't the case, but let's say there's 30 desks, it's 30. Everybody cool? Okay, so what's a set? I've just given you 3 examples of a set. A set, the set of individuals over 60 in the room right now, 0. Okay, so it doesn't have to be a group. Set of individuals in the room over 40, 1, me. Set of individuals in the room between 10 and 20, 30. So what are sets? You're actually on the right track. I'm not trying to shut you down. What? Ratios? Oh. A number of something. A number. Okay. Now we're getting warm. A set is... And make sure all that ink is going to stay there. A set is any amount of data. Oop, that didn't work. You can count. Okay? So in this room, we could do all kinds of sets, couldn't we? Right? We could do the set of people who have laces in their shoes. We could do the set of people wearing more than one layer of clothing. We could do the set of people with hair that touches their shoulders. We could do a million different sets. Everybody cool? And each of those sets is made up of things we would count. Everybody good? How many people have earphones? How many people have cell phones? How many people have an iPhone? How many people have a Samsung? How many people have an LG? Whatever. We could do a million different sets. Everybody good? Okay. So the set is any amount of data that you can count. Any amount. Including 0. Cool? Okay. Next word. An element. An element is any single piece of data in a set. So, go back to my example, any of the examples I gave you. Let's use that one. People greater than 60 in the room. How many? 0. People greater than 40 in the room. 1. Right? And then people 10 to 20 in the room, that was 30 of us. Everybody cool? Everybody cool? Okay, so how many elements are in this set? How many elements are in this set? What? 2? 3? There's 3 people in the room over 40? In a set, yeah. So 1, right? I am the only element of this set. Yes? What happens if Mr. DeVries walked in the room? Well, I'm asking you to guess. You probably think he's 75. I hope not. 2. Okay. What if Miss Johnson walked in the room?
Well, she's like 100.
MJ is very old. So if MJ walks in the room, what happens to this set? Me, DeVries, and MJ are in the room. How big is it? No, wait. Me, DeVries, and MJ are in the room. So how many elements are in this set now? 3. Me, DeVries, Johnson, and MJ are in the room. Now how many? You think Miss Johnson's 40? 3. No, Miss Johnson is not 40. Oh, I'm trying to guess. I'm trying to get how old you people think we all are. Miss Johnson is like 27, if that. No, she's not. The English teacher, Miss Johnson? No way. She's not 40. She's 35. No way. Shut up. No. No way she's 35. She's in her 30s? Well, see, the problem with all this is as you guys are super young, I am super old. And I am bad at telling people whose ages are younger than me. Just like you guys are bad at telling ages of people who are older than you. Because you all think that once you're 30, you're all dead anyway. So, it's all downhill from there. Right? Really? In her 30s? Wow. Okay. We're talking about the same lady, right? Teaches English, first floor, that end of the hall? Huh. I would have guessed younger. Yeah. I've only seen her a little bit. All right. So everyone's cool with elements and sets? Elements make up sets. Oh, so here it's 30, right? Now what happens? What happens if we all get up and go across all of Mr. Keeley's room? How big does this set get? Goes to 60. So there's 60 elements. Each of you is an element of the set. Okay? If we go over there, what happens to this set? 2, because Keeley, I think, is 40. I don't know. Because apparently I'm bad with ages as well. You guys are all teenagers, right? None of you are 25? You ever see that movie, Never Been Kissed? Where Drew Barrymore goes back to high school? It's a funny movie. If you haven't seen it, it's pretty funny. That's with Zac Efron, isn't it? Who's the old dude in that? It is funny, yeah. I can't remember who the old guy is, because there have been so many of those movies where the bodies change, and Freaky Friday and all that crap. Okay. Now, next new word. Relation. What do you think a relation is? Yeah, that's... They had to go back to the first grade, because that was the level of intelligence you needed to enjoy the movie Billy Madison. Anybody past grade 1. All right. What do you think a relation is? You guys know what relation means in English. What do you think it means in math? You're that close. Change one word in that. A relation between... Because... change one word in that. Elements. Excellent. What does a relation mean? Okay. So this room is a set, yes? There are people in this room. That's a set. We could have smaller sets, couldn't we? Kids, old people. Yeah? Okay. That room right next door, is there 2 sets in there? What are there? Kids and an old person, yeah? Right? Who next door there would this element relate to? Mr. DeVries. Who would these elements relate to? All the kids in the desks. Everybody good? Yeah? Okay. So relation is any time we compare elements. I'm trying to get this all written before it wakes up. Damn. Compare elements of one set to another. Everybody cool? Now, the reason this is important to understand this is because people will use this knowledge to make you guys make bad decisions, especially around election time. Politicians really like to compare things that shouldn't be compared. They take 2 different sets and they compare them, and they make it seem like they had something to do with it. Okay? So let's say, for example, something happens in the world and the Canadian dollar starts to be worth more and more money, right? Like a few years ago when the Canadian dollar was almost equal to the American dollar. So we would go down to America and we'd be buying things in America at American prices with Canadian money, and it was almost the same, right? That had nothing to do with the politicians at the time. But there happened to be an election then, and all the politicians for the party that was in charge were like, look what we've done. We've gotten our dollar equal with America. And it had nothing to do with them. You follow me? If you want to see something really funny, and we don't really have time today, but hopefully I'll have time in the next day or two, there's a website that shows taking one set of data and comparing it to another set of data and having them work out the same. And let me give you one of the examples. One of the examples is it puts on a graph how many people have died in the United States because they have suffocated because they've been tangled up in their bed sheets. Everybody understand? Yes, it does happen. Okay? Wait. You understand that there is a set of elements there, right? There are people that has happened to, so we have a set, yeah? Now, we can count anything else, can't we? The people that made this website, and they do it as a joke, they had another set. And the other set was the amount of movies that Nicolas Cage made in any given year. Okay, you with me? You all know who Nicolas Cage is, right? The guy from National Treasure. That guy, right? He doesn't make great movies. He was in The Wicker Man, if you saw that piece of garbage. His movies are bad. Hey. No, I do not. Right. So, on the list of people who have died by suffocating in their bed sheets, it goes up and down every year, right? So it makes a graph. You with me? If you take the graph of movies Nicolas Cage have made and put it on top of the graph for people who die in their bed sheets, as the people who die go up, Nicolas Cage's movies go up. Is that an actual relation? No. But people do stuff like that with data and elements all the time to try and fool you into thinking there is a relationship between things when there really isn't. And when we have a few moments, I'll show you some of those graphs because they're really funny. Another one is how many people die in cheese-related incidents. Yeah. No, it's really funny. I'll show you guys. I hope to show you guys a little later today. So, here I have a graph. Yes? Yo.
Could you go just a little bit, just showing the last bit?
Okay.
Never mind, he has it. I can talk.
Okay. Here I have a graph. We are going to be making a crap ton of graphs in this class from here on in, especially in this unit. A graph in this unit needs a few things. You should write them down. One of the things it needs is a title. All your graphs need to have a title. And the title is usually what your one of the sets involved. Your graphs need two more things. One, they need a scale. And they need, wait, that's actually not a scale. I'm sorry, you guys. They need an amount and a scale. So this is 90. So I've got the amounts, yes? But do I have a scale there? 90 what? What do you think that is? Centimeters. Great. So there I've got a scale. Everybody cool? Yeah? All right. And then they also need the other set. This is one set. This is another set. This down here, does it have a scale? What are these things? They're the dogs. So it now has its scale. Everybody cool? So I've got my the two things I'm counting, which have a name. I'm going to talk about them in a minute. Okay? Everybody good? All right. Now, we know that this and this, and I'm going to use highlighting, yellow, yellow, these are what we call axes, which is the plural form of the word axis, which you guys learned in grade 9, right? When you guys were doing graphing in grade 9, there was the x-axis and the y-axis. And that was this thing, right? Over 6, up 3. Everybody remembers this from the 9th grade, right? Same thing here. We need a vertical and a horizontal axis. And when you pluralize it, it is axes. Now, here is something that you guys need to be aware of. 99% of the time, certain information goes on the vertical axis and certain information goes on the horizontal axis. It's only 99% of the time, though. It's not every time. So you actually have to know the difference between the two of them. Okay? But before we do that, I want to talk about this little. I want to make sure everyone can read the graph. Okay? And what I am doing from that will tell you where I am going with what I just said. So, for example, what is the first element of the set of dogs on this graph? Hound. Excellent. Everyone agree? So the hound is one element of the graph, yes? Excellent. Can you tell me how tall the hound is? Yeah, the average height of a hound. What is it? 60 centimeters. So what do I have now? I have an element, I have another element, and I have a relation now, don't I? So if I say, how tall is a hound? You all know he's 60 centimeters. What if I say this? What dog has an average height of 60 centimeters? Hound. Everybody cool? Easy peasy. You can go both ways, right? Great. What's the next one? Chihuahua, which shouldn't even be a dog, but whatever. We're stuck with them. How tall are they? Okay, 11 centimeters. Is it still a relation? Right? What dog's 11 centimeters tall? Chihuahua. Got it. No problem. What's the next one? Corgi. If you don't know what a Corgi is, they're the dogs that the Queen has. They look like a regular dog, and they're kind of bushy, but they got really short little legs. They're weird looking. But they're not like dachshunds. I'm going to show you it in a minute. You read my mind. Nice. How tall is the Corgi? 30. Excellent. And what's next? Lab. How tall is he? 45. What's next? Shepherd. How tall is he? 45. And lastly is the giant, the Malamute, which is a giant dog. How tall is he? 80. Now, is everybody cool? Everybody understands I've got a set of elements, dogs. I have a set of heights over here. Everybody cool? Now, can you tell me the height of every single dog in this set? Yes. If I give you the height, can you tell me what dog I'm talking about? You can't, can you? What dog is 30 centimeters tall? Corgi. What dog is 80 centimeters tall? Malamute. What dog's 45 centimeters tall? But I'm only asking you about one dog. Which dog is 45 centimeters tall? You cannot tell me. Do you understand? That makes this a special kind of relationship. All right? But the point, all I need you to take away from this is that they are indeed related. Is everybody cool? Right? Okay. Let's turn the page over and we're going to do some work with that. I need this both to be visible. That's why I haven't slid down further. This is information you guys need to refer to answer this question. Okay? So I'm going to remind you, we're not going to write it down. A relation is any time we take one piece, one element, and compare it to another element. Right? So this graph that is in your book is a relation between dog type and dog height. Yes? Okay. A function is a special relation when there is only one element in one set relating to one element in the other set. Is everybody cool? So, if I only had one dog on this graph, if I only have the hound, is that a function? Does the one element, hound, relate to one element in height? Yes, so it's a function. Everybody cool? Okay. What if I add the Chihuahua? Is it still a function? Yes, because Chihuahua's only related to 11, right? What if I add the Corgi? Is it still a function? Yeah. What happens here? And that was supposed to change color to blue, but of course it didn't. What happens there? Yeah, that should have changed to blue. Once I get to there, shepherd relates to two of them, doesn't it? And lab relates to two of them. So once that happens, we don't have a function, which I'm going to highlight as another new word. This is a relation. Is everybody cool? Yeah? Everybody understands? Okay. Now, let's take this one step further without something you have in front of us. Go back to our example. This class next door, yes? Is that a relation or a function? It is a function. Why? You had a 50-50 shot. It is a function, though. Why? How many teachers are in there? How many teachers are in here? One. One element of this set equals one element over there, right? How many kids? Say there's 30. How many kids here? 30. Everybody got it? Okay. What if there were 2 teachers in the room next door? Is there? That screws things up. Well, no, it doesn't. Okay. Carlin says there's a student teacher in there. So, can we do... Then it's what? Is it a function or a relation? It's a relation because you don't know what adult next door I would be related with. Right? Everybody with me? Everybody good? Sweet. Easy peasy lemon squeezy. So, let's have a look and see if you really understand this. Every month in the year relates to a number of days. Is that true? Does every month have days in it? So is it true? Excellent. What is the first set? What is set 1? No. What's the set? Months. Set 1 is the months. What are the elements of that set? No. Read what the element definition is if you don't remember. I'll show you on the screen if you don't want to flip back a page. What's an element? Any single piece of data in a set. So what are the elements of the set of months? January, February, March, April, May, June, July, August, September, October, November, December, right? I'm only going to write a couple. And I'm going to be so lazy. Jan, Feb, March, April. Okay? April. Everybody good? Everybody understands, yeah? What's the other set? Is days, yes? How many elements are in that set? No. Number of days? No. Oh my good gravy, guys. Month, days. 30 or 31 or 28 or 29. Does everybody understand why? Everybody understands, yeah? Okay. So now, is it a relation? All right, let's check. Does January have a certain amount of days? How many? 31. So that's a relation, right? So January relates to 31. Cool? Okay. What about February? That depends. 28 and 29, yes? Now, if I say to you, what month has only 29 days? Can you tell me what month I am speaking of? You know it's February, don't you? If I say what month has 28 days, do you know what I am speaking of? Or did I just trick you with both of them? I tricked you. Why? Every month has them, right? Let's change the question. What month has only 29 days? February. And then you know I'm speaking about February, right? What month has only 28 days? February. That's why I said only. Okay. What about March? March is 31. What's April? 30. Right? Everybody cool? May, 31. June, 30. Does everybody agree that I am taking one element of one set, a month, and relating it with an element of the other set, a number of days? Is it a function? No, it isn't. Why? There's multiple months of 31 days, multiple months of 30 days. What month has 30 days? I'm thinking of a month with 30 days. What month has only 30 days? Can you tell me?
June.
Wrong. Not the month I was thinking of. No. Actually, I was thinking about April because April's my birthday month. April 27th. Sadly, you guys won't be in my class on April 27th, but that's okay. You can take care of your wanting to give me gifts with Christmas.
Robert's April 29th.
Is he?
Yeah.
Huh.
Carlin's April 4th.
So everyone is aware that this is a relation, right? Because you cannot tell me what month of which I am thinking, yeah? Let's look at the next one. Every name on my class list relates to a student in the class. Is that a relate? What are the two sets? What is set 1? Names. Excellent. And on my class list, I have 30 names, yes? Everyone agree? Right? So I got Connor, B, I got Wyatt, P. Everybody with me? I could list out all 30. Cool? Now, and what's set 2? Right, it's the actual person. You with me? When I say, go find Connor Boisimer, boom, I can find him, right? If I say, what's that kid's name? I can find it, right? So is this a function or a relation? This is a function. Is it always a function? How would it not be a function? What would make it not a function? We have 2 Daniels. Going by first name, this is not a function, is it? Going by last name, is it? If I use first and last name. What if I go by only last name? Is it a function? No, because there's tons of kids in this building with the same name, right? My grade 10 pre-dip class has 4 Sandus in it. If I went by, hey, Sandu, how many heads would turn to look at me? 4, right? Would they know which kid I meant? No. What if I said, hey, Avapal? He's not in this class, but Avapal Sandhu is in my honors class. Would he know I was speaking to him? Yes. Will even that always work? No, because in my homeroom, I have 2 Jasreet Dillons. Right? So if I say, hey, Jasreet Dillon, how many kids are going to look at me? 2. Understand? I even think you guys have the same middle initial, don't you? Yeah. I can't even do that. But everybody's cool, yeah? Whether it's a relation or a function. If I use first and last names, most of the time it's going to be a function, yeah? Because I can say, Eden Bedwell, that's Eden Bedwell. There's no other Eden Bedwells. Got it? Unless you do something mean on like to a sub and change names. We used to do that to subs all the time. It was good times. And then you would always act like the best thing to do would be to look around the class and see who wasn't here. Like today, Daniel Wilton's not here. And if you were a sub, or if I was a sub, you would say, Carlin could say, I'm Daniel Wilton. And then act like a real dink. And then the sub would write down, Daniel Wilton was a real dink. And then the teacher the next day would be like, why you got to be that way? And then Carlin would be like, and Dad would be like, I wasn't even here yesterday. Says right here you were being a dink. I never, ever did that. Not once. And?
You said you did. You said you did it before.
What are you talking about? Shut up. No, I said no such thing. I never did that. All right. Okay. This is where we're going to get to something a little weird. Some of you will have studied this in the 10th grade, 9th grade, and some of you will not have. Okay, so please pay attention. There's 2 variables here. There is the dependent variable, and there is the independent variable. And they are quite different. In English, what does the word dependent mean? In English, forget math class, what does dependent mean? You rely on something else, yeah? Right? Everybody with me? And independent means what? You're all by yourself. Nothing matters, yeah? Everybody cool with that? Same thing here. The dependent variable changes when the independent variable changes. Picking up what I'm putting down? So the easiest way to do this isn't to define it. The easiest way to do this is to use examples, all right? So the first thing I'm going to do is I'm going to write this down. I abbreviate this as DV because I'm lazy, which means I abbreviate that as IV. Everybody cool? All right. Now, again, I'm going to use examples, okay? Let's use, this is always a good one, okay? I have two sets of data on each and every one of you, yes? I have your name and I have your grade in the class. You with me? Everybody agree? Okay, so I've got two sets. One of those is the dependent variable and one of them is the independent variable. Which do you think is which? So this is my example. I'm going to come over here and I'm going to write, I have two sets. I have student and I have grade. Which of those is independent and which of them is dependent? Do you think? Wyatt, you put your hand up. I'm going with you. The student is independent. Why do you think that is? Oh, I see. You're looking at their actual grade, like grade 10 or 11 or 12. I'm talking about their grade in the class, like A, B, C, or D. But still, student is independent. Why? Because of what you just said. No matter what I am speaking of, you're Wyatt. It doesn't matter what the other set is. You are Wyatt. You stand by yourself, right? Everybody understand? So this is my independent variable, right? Because no matter what I am counting, that kid right there is Wyatt. I could be counting his height. I could be counting his age. I could be counting his weight. I could be counting whether or not he likes cats. He is Wyatt. Everybody cool? And the other one is the grade. That's why it's highlighted in yellow. Because the grade depends on what kid I am speaking of. Yes? Everybody cool? If I said 84%, does that mean anything? No, because it depends on what the kid is. But if I say John Smith, can you then tell me what grade he is getting? Does everybody understand? Okay? Now there's a little bit of stuff that you got to know about this. One, the dependent variable is usually graphed on the y-axis. And the dependent variable is, of course, usually, that's going to cross out in black even though I tapped the blue highlighter. Where would the deep independent variable be graphed then? On the x-axis. But you can't rely on that, okay? Because graphs can be turned around to fit better on a page. You understand? What you got to do is actually know the difference between them, okay? So I like to do this. The independent variable is the one that's the same always. So for example, Wyatt is always Wyatt, right? Your grade in school, in a class, changes. It depends on what class you're in. And it depends on the time of year, right? If I give you guys one quiz and you all get 100% on it, everyone's getting 100%, right? But as we go further into the year, you're still Wyatt, but your grade changes. Is everybody cool? Everybody understands? Difference between independent and dependent variable? Okay. Now, these are related to them. It's a new word. The domain, please notice I've highlighted it in blue. So the domain relates to which one? Independent or dependent variable? independent. The domain is the set of elements in the independent variable. So if you guys are the independent variables, each of you is an independent variable, the domain of this relationship is all of you. Cool? So obviously, duh, what's the range? It's the set of elements in the DV. Everybody good? It'll show up in a sec. It'll show up in a sec. Excellent. Now, I'm going to stop for one moment. Everybody doesn't have to write. Let's have a look back at this one graph that we have seen. Which of those is this? Does this graph follow the example I gave you? Is the independent variable on the x-axis? Yeah, because the height that you're going to find depends on the dog you are asking about, yes? Because if I say 45, you don't know what dog I am speaking of. Does everybody understand? So this follows that rule. Everybody good? What if I turned it sideways and made the graph look like this? Height and dog. Then even though I've turned it sideways, this is still my independent variable, even though it's on the y-axis now. Is everybody okay with that? You got to actually know the difference between the two. Everybody cool? Right? Because if I say 45, you don't know what dog I'm speaking of. But if I say shepherd, you know it's 45. Cool? All right, let's see if you really get it, and then we're almost done for the day, and we'll go over the test. You can tell how old these notes are because minimum wage was still $9.50. What is it now? $10.25? 11? 11.35? And you guys complain? You know what my first minimum wage job was? You guess. How old do you think? You think I'm 60. How old do you think my first minimum wage job was? No. Higher. Keep going. Higher. Higher? Higher? Lower. Huh? Lower. 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 4. My first job was $4 an hour. If you were under 18, if you were over 18, they gave you $4.25 because they assumed you were living out of your house and you needed 25 cents extra an hour to afford to live. $4.25 an hour. My first job was at a place called Burger Brothers, which was like a robbery, like just like a McDonald's fast foodie type place. There were only about 6 of them. They were in, there was a couple in Surrey, there was a couple in Richmond, and then there was one in my stupid small town. It should have gotten better because they were the best burgers ever. They were so good, but they had a horrible name. They were called Maxi Burgers. Picking up what I'm putting down? So people would come in and order a double Maxi. I know, right? It was a horrible name. But the burgers were delicious. So anyway, my friend Sandy is working at Flying Wedge Pizza, which also used to be in Abbotsford, but it's not anymore. It's the best pizza. It's so good. Oh yeah? Why'd he shut it down? I love that pizza. It made me so happy because then I grew up in Vancouver where there's Flying Wedge Pizza. I was like, oh, it's so good. And then driving through Abbotsford, oh my God, Flying Wedge Pizza. I'm going for pizza. Anyways, so she's paid $9.50 an hour. Her hours of work are related with her pay, right? So what are the 2 sets of data here? Excellent. So set 1 is hours, and set 2 is pay. Agreed? Okay. Which one of those is independent and which one is dependent?
Independent is fine.
Oops. Talk amongst yourselves. Figure it out. Take a moment. Laying down a fat bass line. Don't make fun of me, Noah. It's hurtful. I've already been made fun of. Thinks I'm 60 years old. I would have been okay with 50 because I got the gray hair. It makes me sad, but I would have been okay. But 60? That's mean, man. It's just mean. I'm not mean to you. When? Huh? I'm never mean to you. You can't even name one time. Except today when you thought I was 60. But you won't tell me how to say it right. No. 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 Yeah. Oh, that didn't work. It always works on cartoons. All right, what's the independent variable? Emma. The hours are the independent variable. Absolutely right. And the pay is the dependent. Why? Emma. Pay depends on how long you work, right? And will hours pass even if you're not working? Yeah. You guys have been here for an hour. How many of you got paid? None. Huh? I did, but I don't get paid by the hour. You understand? We get paid a yearly salary divided by 26. I lie. Divided by 24. Because we get paid twice a month. So they give us X amount of dollars divided by 24, and that's what I get a paycheck every month. Every 15th and 31st or 30th. Middle of the month, end of the month. That's here. Another place I worked divided my salary by 26. They paid us every 2 weeks. Another place I worked a place I was going to work and this was the weirdest place ever. They were going to give me all of my salary for half the year, so September to January. They were going to give it to me all at once, which is kind of weird. I didn't end up working there because I would have been like, $30,000, woohoo, making it rain. And then the middle of December, I'd be like, can I get a coffee? Yeah. My brother, his last job, they paid him every week. Anyway. Hours are independent because everybody is passing hours, yes? But unless you're at a job, you're not getting paid. Cool? Okay. So what is the domain and range? The domain, is that the IV or the DV? Great. So what are the possibilities for my domain? Can I work anything less than 0 hours? Can I work negative hours? No. So the domain is 0, right? What's the most I could work in a week for that wage? Do you guys know? How many hours can I work in a week for that wage before that wage would change? How much? 40. So the domain is 0 to 40. Agreed? Everyone understand? Now we write this in a special way. Please pay attention. You put the lowest number first. 0. 0 is less than or equal to your hours worked. Everybody understand? Because your hours, 0 is the lowest you can go. Everybody cool? But your hours must also be less than or equal to 40. Everybody understand? Okay. What then is my range? What's the lowest amount of money I could make? 0. If I don't work, I don't get paid. What's the most amount of money I can make? 40 times 950, yes? So if you do that math, it's $380, isn't it? Somebody with their calculator, do 40 times 9.5. 380. Now here's where it gets weird. Can I write this like this? Would I be allowed? Why do you think not? You've been lucky. You've hit them both right. Time to go to Vegas. Because can I make $9.50? Yeah, if I work 1 hour. What if I work an hour and 1 minute? Do you get paid by the minute in most places? Right? I don't know how you guys work, how it works at your jobs now, but when I was working jobs like you guys work, the best we got paid was a quarter of an hour. Right? If you worked for 10 extra minutes, tough luck. But if you worked 15 extra minutes, you got an extra quarter of an hour pay. But if you worked 18 extra minutes, you still only got 15. Is it like that still? I've heard that McDonald's now has computerized and you're paid to the minute. Is that true? Do you actually work there? Yeah? And they're paid to the minute now? Cool. Okay. So when I wrote these notes, you couldn't write it this way. But for our intents and purposes, we are going to write it this way, right? So what is the lowest amount of money I could get paid? 0. Lower than or equal to what? Pay, which has to be lower than or equal to what? 380. Is everybody cool? Now, is it a function or is it a relation? Remember, functions have one element of one set equals one element of the other set. Is this a function? If I work 1 hour, do you know how much I get paid? Excellent. If I get paid $19, do you know how many hours I worked? How many? 2. If I work 10 hours, how much do I get paid? $95, right? If I got paid $190, do you know how many hours I worked? 20. Okay. Is it a function? Yes. So this is a function because every hour value gives a different pay. Right? So every dependent variable value gives me a different, did I just say dependent? Every independent variable value gives me a different dependent variable. Everybody cool? All right, let's look at the next one. How are these written? No. What does that mean when you see 1, 3 in brackets like that? X and Y, absolutely right. So I have X's and I have Y's. Which of them is the independent variable? X's or Y's? X's are the independent variable, yes? So what are the options for X? 1, 2, 3, 4. What's the Y that goes with 1? 3. What's the Y that goes with 2? 6. What's the Y that goes with 3? What's the Y that goes with 4? Does every X equal 1 Y? Yes. So is it a function? Yes. That is a function because every X gives 1 Y. That should show up in a second. Is everybody cool? Okay, look at the next one. What are my x's? 1, 0, -1. I don't write 0 again because I've already got it. Cool? What is the y value that goes with 1? 0. What is the y value that goes with 0? 1 and -1. What's the y value that goes with -1? 0. Is that a function? No. This is a relation. Why? Because x equals 0 gives 2 y values. Everybody cool? Okay. And C. What are my x values? 2, 4, 6, 8. What are the y values? What goes with 2? 3, 5, 7, 9. Function or not? Function. Why is it a function? Every x gives 1 y value, yes? What's different about D? It's actually on a graph. So where do I get my x and y values from? From the graph. What are my x values? What's this x value? -3. What's this one? Actually, I guess we should do the y value there. What's the y value there? 2. What's the x value there? -2. What happens at -2? What's that and that? They're two different y values, aren't they? So at -2, I could be -1 or I could be -3, yes? So right there, I'm screwed, aren't I? What does that make it? That makes it a relation. Because for every x, for that x value, I have 2 y values. Everybody cool? Tomorrow I'm going to give you another word for that. But your homework tonight is all you have to do is tell me the domain and range of those 4. I already talked about what domain and range is. All you got to do is figure it out. Okay? You got to write down 4 things. Robert. Of course I can. Now, it is 10:50. I did not get enough time to go over the test. But would you like to see it? See what you got. And we can go over it tomorrow. Okay? You can always check my mark, but that doesn't actually show it to you. Because you've still got 7 minutes left in class. That's enough time to at least see what you got, compare with your neighbors. Yes, you did. I have it recorded. I asked you numerous times. Yes. Okay. Josh. Yes. Okay. I apologize. Now, if you told me, I'll say it right. It's frustrating because there's a kid in my other class, Har, who wants to be Jashin. Oh, Jashin. He didn't tell me he wants to be Jashin. He wants to be Jashin.
The Aaron calls him Jazz. Or Jason.
Jason? That makes no sense. Yeah. Well, no, I can't because I'm way over here, right? Remember, once again, do not leave. Do not leave with these. I need them back. And tomorrow we'll go over them. Guys, I feel bad. The homework I assigned you, I feel bad not showing you how to do the first one. Okay. What is the domain in number 4? In this one, what's the domain? 1, 2, 3, and 4. Is it everything between? Or is it 1, 2, 3, and 4? It's 1, 2, 3, and 4. So we got it. I won't do the brackets. I'll explain the brackets later. It's 1, 2, 3, and 4. Could I say a 1.5? No, because I don't have that data. What's the range? 3, 6, 9, 12. Now, please notice they happen to line up. That might not always be the case. Everybody cool? Like, that's not going to be the case here, is it? Right? Because of that. Everybody good? Okay. So really you only have to do 3 things for homework tonight.